Mrs. Thomas is in hot water.
Yeah, this is yeah, huge upgrade from
Likes to camp out at,
it's gonna be great.
right?
Field snow.
Oh, yeah.
Whatever.
So maybe next time, if he feels. Okay, sounds good.
All right, we can get started. Welcome to Weather Watch. I'll be going over a brief look at the current weather and then a little bit of forecast, and we'll have two other groups of presenters today. So first, could we start at the AOS satellite page, and we'll pull up the color viz. Luke, please, Pete. Perfect. So we can see there's a big cloud streak from down into Mexico, all the way extending into the northern Atlantic. This is producing a lot of heavy precipitation over the southeast and has been kind of lingering. I believe this is attached to the system that moved through Wednesday and Thursday, and it's just the remnant cold front being more of a stationary front where you get warm, moist flow off the Gulf and colder, drier flow, producing this heavy band that doesn't really move that much until another system comes along and sweeps it away. And you can notice there's also, we'll look at this closer, but there's a region of smoke over maybe the panhandle of Oklahoma all the way up into Iowa at this time. So it might get a little smokier throughout the day. I'm not sure how thick this smoke is, if it will even move into our region, but we'll see that better. You can notice there's clear skies, so you can see the snow cover in the northern part of Wisconsin, Minnesota, the Dakotas, and into Wyoming and Montana. And then there's another system beginning to approach the western United States here, and is going to bring heavy snow and rain into Oregon and more northern Pacific Northwest. So California will be spared, but there's still going to be a region of heavy precipitation with that system as well. And overall for us, relatively quiet. It's been sunny for 2 days now, which has been nice. I can't remember when that's happened last this year. Usually you get an hour of sun and then clouds, but we'll see sunnier conditions and warmer conditions as well. So that's much welcomed. Let's go back.
One second, Patrick.
Oh, yeah.
Look at the holes in the stratocumulus off the Baja California. I don't know what they call it. There's a name for those little cells.
Yeah.
But it's got a name, but they're really interesting. Just curious.
Oh, I forget that too,
Yeah.
yeah.
Begins with an A, doesn't it, or something?
I think so, and it's something long.
Yeah, I know, I can't think of what it is.
That is pretty, yeah. So let's go back a click, and we'll zoom into the Midwest. So could we go to the all goes east image of these? And then Midwest, and then the Rayleigh 3-hour loop. So here's that smoke band, you can notice. It is prompting air quality concerns for Lincoln, where I'm from. But into Iowa, you can see this band of smoke, and it extends all the way down into Oklahoma. So this is kind of interesting. It might be even nudging into Dubuque, maybe even Platteville right now. It's hard to tell because there's cloud cover that might be polluting it, but there is a region of smoke. And then you can notice the snow cover to our north, which luckily is going to keep us warm and them cold with this warm up. Okay, so let's go to...
Another fire going on down here in Kansas.
Yeah.
Oh yeah,
Yeah.
definitely. These are controlled burns, so this is not anything to be concerned about, but this is what's fueling all of this smoke.
This is interesting too. Is there ice on this river back here?
I was looking at that too. It looks like, yeah, there's ice, and then it's ice-free, and then there's ice around this bend, and then it's ice-free, so...
They got ice flows in some of the big rivers. That's the Missouri, I think, isn't it?
I think so, yeah.
Yeah.
And they can get ice flows at certain points of that.
And we'll see that there's concerns for ice jams and flooding in the current one. So could we go to the picture that I sent you, Pete, please? So this is a look at the surface analysis from yesterday. And I just wanted to look at, we kind of got the conclusion of why there's smoke, but at first I didn't really know why there was smoke, and a pretty wide swath of smoke in the Midwest. But here's a look at the surface map from yesterday. So we had a high pressure system sitting over northern Missouri, and all of these wind barbs are less than 10 knots, 10 knots or less, which is very rare for this part of the country, I would say. It's always pretty windy in this region, and so Kansas sent out a bunch of crews to do controlled burns to get rid of all the old vegetation yesterday. And I found this from Twitter. So, and you notice we have a high pressure, so winds go clockwise around a high. That fits perfectly with the band of smoke, how it was swept up from Kansas into Iowa and then into our region as well. So this was my best guess as to why there was that big plume of smoke yesterday. And then some of the fire, since the winds are weaker and there's not really a tight gradient of isobars, some of the winds from Kansas might have been pushing that smoke band towards Oklahoma and gave it that appearance that it's originating from Oklahoma as well. So, and you can also notice the dew points are very low compared to the surface temps here. So dew point depression's at the surface about like 40 degrees Fahrenheit. So that's dry, weak winds. That's probably a good time to do controlled burns, but obviously it's producing some hazards and over places to our west right now. Okay, and then let's go to weather.gov, please, Pete. And if we just go to the main page. And then we'll just look at this hazard map here. So we can notice there's sort of three big picture places. First, there's the flooding due to the stationary front that's sitting over the southeast. It's especially hitting like Lake Charles, Louisiana, hard, but as this progresses, I'm sure there'll be more flood watches and concerns into more of the southeast. There's two areas of red flag warnings, so very dry and windy conditions. This is actually for tomorrow, I believe, in the Central Plains, and then this northeast portion is for today, so very dry, very windy. And then you can notice hydrological outlooks. These are the lighter green colors. Those are for snow melt, ice jams, river flooding, everything that happens when you get 70-degree temperatures coming into regions that have 2 to 3 feet of snow on the ground. So you can notice these are starting to pop up, and I'm sure they'll pop up around North Dakota as well, but they just got hit with a lot of snow, so they probably won't be as cold, but there will still be flooding concerns for most of the northern United States here. And then the last thing I want to show, we can go to pivotal weather. I think you had it up. Maybe. We can do this, here, the CPC outlook, right here. That'll be perfect. So it's going to be warm. It's going to get warm. This is pretty clear in the probabilities of temperature. It's a very high probability around the northeast, but even into our region as well. And if we go to 8 to 14 as well, there's a high probability that we will stay warm, but the majority of the eastern United States here. So we can look at just how warm we'll get. So we could go to models, please, and we'll do the GFS. And then we go to temperature and wind bars. Yeah, perfect. And then we'll just click through. Let's go to 6 hours. So this is a look at right now from the GFS. You can notice we have that high pressure still lingering. It shifted over to the east compared to what I showed from Thursday. But we have southerly flow. So all this southerly flow is bringing up warm air from the Gulf, from the south, into our region. And you can really tell where that snow band was situated, where there's still snow cover versus bare ground. You have temperatures 70s versus 30s and 40s here. And we'll just click through daily. So if we could go to 30 hours, you can see we still have southerly flow. We still have warm temperatures. That snow band is still evident on the ground, even in the models. Temperatures close to 80 in Kansas and Nebraska. And let's keep going. We'll go to 54. This is now Sunday. We still are in a southerly flow regime. That gradient due to the snow is becoming weaker and weaker, so that's the flooding concern that we saw in the weather.gov outlet page. Go ahead to Monday. Now we're still in southerly flow, maybe weaker, but we still have persistent southerly flow, clear skies, we're still warm. We'll go to Tuesday now, and then we'll actually look at the temperatures. These are like 60s. Now if we could hover over our region first. So upper 60s for our case. Let's go to Montana. near 80, where there's still snow cover on the ground today. So that's going to be interesting if that actually verifies. That's very warm for this time of year. A wide swath of 80s all the way down to New Mexico, all the way up to Montana. That's pretty remarkable. And then we'll keep going. We'll see this pattern persist. There it is again. We're still pretty warm. Let's see what it has for us. Now we're into the 70s. This is Wednesday. And then we'll go another day forward. This is Thursday. We're still into the 70s here. We'll go to Friday. We're still in the 70s here. We go to Saturday. We're still, maybe this is some cloud cover or something, but we're still in the 70s. We'll go to Saturday. Oh, this is Saturday, sorry. We'll go to Sunday. Here's the next push of cold air from the north. So we have more than a week of 60s and 70s ahead of us, which is welcome, yes. But this is, all of this southerly flow is probably going to create a lot of flooding concerns for the northern part of the country. Luckily not anywhere near us because we don't have this persistent snow cover, but regions in North Dakota, Montana, Minnesota will probably have a lot of flooding.
You know, the one silver lining for the flooding threat is that the air is going to be really dry. It doesn't look to me like the Gulf of Mexico ever really gets brought up to high latitude. It just keeps on getting screwed up at the Texas coast. And then, like on Tuesday or Wednesday, there's a really interesting, I don't know what it is, little tropical thing that develops off the
Down there.
coast of Houston.
Yeah. Originally I saw that, yeah. Let's go
2
back.
days back is even more interesting.
Yeah.
Look at that. And that's an interruption of, it looked like by about, what is this? This is on Tuesday. It looked like by about Monday there was an establishment of some flow off the Gulf, but you can see right there, the flow is not off the Gulf of Mexico, it's off the desert southwest up towards us. So that's all because of whatever's going on down there. But that's an interesting little disturbance.
That's right.
Sure looks weird.
I did notice that. In the isobars, because it's every 2, it looks way more impressive than the actual sea level pressure, but still something to watch. Good point, thanks for pointing it out,
So what I mean about the flooding is there'll be sublimation as well as as just melting. So maybe the sublimation will help.
That's right. Yeah.
Keep the water building up.
Yep.
I was gonna go off that, like the rivers, especially in upstate New York, have the same tendency to have the ice jam risk. But the amount of snowpack in like the Duluth, northern Minnesota, and even over to the Dakotas from the other day, I think helps drive the fact that if you're at the NWS, you're going to put a warning out on those states and not on upstate New York. Like Plymouth State University, for example, you can correct me if I'm wrong, doesn't their parking lot like flood every 5 years?
Oh,
A
yeah.
huge ice jam event when it snows on top of rain. They're like substantially impactful events. It's not super wise to like go hiking in river valleys in the spring in these areas. Like,
No.
you might not expect it, but when the thing goes, you're not getting out of the way.
That's right, yeah.
Yeah, there's a school, is it St. Michael's in Winooski, Vermont, which is on the Connecticut River. They have a notoriously bad time with ice jams at late March, early April. I don't know what the situation is this year.
Yeah, that'd be interesting, because the Northeast has been relatively snow-free. I wonder if that's true for Vermont, but I know Massachusetts, Connecticut, New York has been nothing.
Yeah, it's ice on the rivers. I don't know how cold it was, so.
Not really, yeah.
Ski season was a disaster there.
Yeah, that's bad for them. Squaw Valley, than usual.
So that's all I had. Are there anything else people want to comment on?
I was just gonna say like the like consistent southerlies that brought into southern Wisconsin, but they can't seem to make it all the way to the to northern Wisconsin. It's like kind of an interesting like diabatic thermogenesis problem every day. Like how much daytime heating can you get on the clear, the snow clear areas? It's like every day over and over.
Right.
I don't know how far it goes up into the atmosphere, but it's kind of an interesting one, at least a boundary layer situation for sure.
Oh yeah, definitely.
There's a sheet of positive PV on top of snow that just isn't getting involved in anything. Gets enhanced a little at night, but then it doesn't go away in the day, but it doesn't do anything.
Right.
It's really interesting.
Yeah. All right, I'll turn the baton over.
Thanks, Patrick. Good job, Patrick. Your work. Yeah, let's Sorry about how things ended up on the weekend for you, Kalen, at Wrigley Field. That was not what you expected when you were trash talking on Thursday.
Don't worry.
Yeah.
So we will be talking about our adventures to Smelson, Talmadorn, the great field of Iowa.
Awesome.
Nothing particularly interesting occurred. Yeah. But yeah, no, so we went on a little vacation on Friday to look at some beautiful tornadoes in Iowa. And we just want to do a recap of synoptics, mesoscale, and just what we did that day, how it went about. I'll go back one.
Yeah.
So we have two tornadoes here, twins, very rare. This was rated EF4 in the town of Kyoto, and then that was the EF2 on that side. No injuries, no fatalities. It destroyed a house only, so the best thing you can happen, just no major human loss, which is what we want to see.
Yeah.
But overall, this tornado outbreak was very in-depth and did cause damage, which, if you go forward. So this is a quick and overview of the entire outbreak over the 3-day period. So in the field contours, you have the SPC outlooks from March 31st, April 1st, and April 2nd. And in their color codeds are light green's marginal, or general thunderstorm, marginal, flight risk, enhanced, moderate, and 2 separate areas of high risk on March 31st. And in the red boxes are tornado warnings issued from the National Weather Service, and the little triangles are color coded by the tornadoes that occurred and the EF rating that was assigned to them. So the lower ones are light yellows and cyans, whereas the strong ones yellow, orange, red, and if we got an EF5 it would be purple, but we did not want to. Overall, 123 tornadoes occurred over this 2-day period across the Dixie Valley, Midwest, and East Coast, which had a fair bit of a tornado outbreak themselves. 43 were significant, so EF2 or stronger. So that was very, very uncommon. 27 fatalities, unfortunately. Many of them were overnight. This was the 6th most prolific outbreak in the United States for a 24-hour period. That's putting in the ranks of the super outbreaks of 1974, 2011, even the 2020 Easter outbreak, the December 2021 outbreak, so it's a pretty well-known company. 2 main threats on our day, so down in Dixie Valley there's a high risk, and up in the Midwest close to the surface low. And there were multiple consecutive PDS tornado watches, so particularly dangerous tornado watches issued basically from Iowa all the way down to the southern part of Arkansas, which is extremely rare. And tornadoes occur well past sunset in discrete mode, so individual supercells, but as well as a line of squall, well CS tornadoes.
All right, now I'm going to talk a little bit about. I have the pointer. Sorry, it's just. Yeah. I'll talk a little bit about the kind of synoptic setup that primed the environment for this tornado outbreak. So we've got here the 12Z GFS analysis on Friday, March 31st, so 7 a.m. on the day of the outbreak. And so obviously the most conspicuous thing here is this pretty deep trough across kind of the Rockies here, and even starting to form a little bit of a cutoff low here across eastern Colorado, western Nebraska, and southwest South Dakota. And so with that, you've got some pretty impressive jet streak across much of the central United States. 80 knots here in southwest Kansas, Texas Panhandle, and so this is what will kind of pull into the region towards the end of the period. And so one of the things I think that made this outbreak so prolific is kind of the level of the upper forcing associated with it. You can see some really impressive cyclonic curvature here, as well as some difluid flow towards the downstream part of this trough. And so both those, I think, combines to really kind of help initiate storms in the open warm sector, where I feel like it's not as frequent that you get initiation there. And so we'll go a little bit forward here to 0Z on Saturday, and as you can see now, we have this really deep wrapped up cutoff low. This is a 535 height. I haven't looked at these. Those are heights, right, Pete?
Yes.
Okay. So I don't know what that height is. Sorry, I'm not familiar with the units on the.
I think they just dropped the.
Yeah.
Leading five.
Leading five, yeah.
I think so.
So 535 decameter heights there in Omaha, which is pretty impressively low. Also, I'll note some pretty cold temperatures here, -28 in northeast Kansas, yeah. So led to some pretty impressive lapse rates, which Cam will show in the soundings. But you'll note here a really impressive jet stream across there, as well as a pretty impressive aeroclinic zone here, western Missouri, southeast Kansas. And so this led to some really impressive values of wind shear that were very conducive for supercells and tornadoes. And again, you'll note kind of the intense cyclonic curvature here. So you'd expect some really impressive PVA out ahead of that, leading to some dramatic synoptic scale lift across much of the warm sector, which is kind of again like why I thought that this was such a prolific outbreak.
Yeah, the downstream ridge over Wisconsin is much more amplified, just 12 hours here on 12Z on the Saturday compared to 0Z. Look at the difference in the ridges. It's much more amplified.
That's a great point. You can see that really dig and then this really amplify in response to that as well.
Yeah, so the curvature, like you point out, is really, curvature gradient's huge.
It's a great point.
Across northwest, east Missouri.
And then another thing that really kind of contributed to the setup here is some really dry temperatures at 700 millibars. And before I get into that, I'll note also, just keep your eye on kind of the westward tilt of this with height. I'll go back to the 500 millibar chart. You can see the low there, and then at 700 millibar at 12Z, well to its east, and that continues all the way down. I'll show a 925 millibar chart in a second. But that's all to say that this is a very conducive setup as well for surface cyclogenesis, and that's something we'll see later on, which led to some really, really strong surface winds. I don't think I'll have to see if I can find the observation, but the surface cyclone got really quite impressively deep. Anyways, that is to say, what I was going to talk about here on this chart is both, again, to note kind of the jet here, some pretty impressive gradients of height here, leading to some, this is a 60-knot observation here in northeast Kansas, really impressive southwesterly jet at 700 millibar here, as well as some, crazy dew point depressions, like this 25-degree dew point depression.
That one's amazing.
Yeah, so a really, really crazy op there. So that, will lead to a really impressive mid-level dry punch, which we'll see on the visible satellite loop that really aided in surface insulation and led to both, crazy instability and some really impressive low-level lapse rates, which I think also aided in tornadogenesis. But you can also...
Sorry.
Yeah.
I thought Topeka Sounding and Norman at this time were the only ones that had really substantial Cape values.
Yeah,
Everywhere else was still cooking, but those two were already ripe.
Yes, and I think we have the 12Z Topeka Sounding in a couple slides, which is exactly as you said. It was already a very impressive environment. And you can also see the flow is kind of directly from the desert southwest all the way up into the risk area, and that'll be manifest in a really impressive elevated mixed layer. And this was already in place at 12Z, as you said, so there was a lot of elevated convection going on across southeast Iowa, northeast Missouri that went up into northern Illinois and produced really impressive hail. Do you remember what the biggest report was?
3 inches. It was a whole bunch of 2+.
Yeah.
I didn't see the biggest one myself.
So quite a significant hail event, likely largely as a consequence of that EML. And then I'll also just show kind of the 925 millibar chart here, just so we can get a better idea of how things look closer to the surface. You can see this pretty impressive cyclone here, and I think the other thing I'll really draw your attention to is this is, 60 knots, 55 knots here at Lincoln is a pretty crazy value for a 925 millibar observations at 12 in the morning. And then you can also see, obviously, just flow directly off the Gulf here. So some really impressive moisture advection that led to some pretty deep moisture that we'll see in the soundings. Pete, are these dew point depressions again on the obs?
Yeah, they must be because...
I think so, yeah. So you can see, largely almost saturated here across much of the southern Mississippi Valley into the eastern plains, 2-degree depression at Little Rock. And there were actually tornadoes in Little Rock here, maybe, do you remember what time the Little Rock tornado was? Yeah, so maybe about 6 hours after this, there were some significant tornadoes in Little Rock. Yeah, so, just a really impressive setup synoptically for a widespread severe weather outbreak. And you'll note the 800 or the 925 millibar low is centered well to the east of the upper low, so you'll have really impressive ascent over this and the surface low that really leads to some impressive mass evacuation and incredible surface psychogenesis.
I read that there were some trucks that got blown over on I-80 in northern Illinois, and I don't know if that was from just the synoptic winds or if that was storm related.
Yeah, there were really impressive winds behind even the front and the storms as well. So yeah, I could have been some of both.
Let me see the 700 millibar map at 12Z.
Absolutely.
Look at in the panhandle of Texas, there's cold advection all the way to the Oklahoma
Yeah.
border. And then go back to 950, or 925. Oh, I guess there's barely, there is a little bit of cold advection in that same region. But further south, it looks like the cold advection at 700 millibars outruns it at 925, which is destabilizing.
Good
Like
point.
they love it.
Yeah, that's a great point. Yeah.
So
So,
everything's
you know,
kind of wild.
exactly. Yeah, I mean, it was really a really impressive confluence of a number of different factors.
Isaac,
Yeah.
and back on the 925, like that 65 knot flag is running into a region of baroclinicity, and then it's a 10 knot flag. Right there,
Great
right?
point.
Am I reading that right? Is
Yeah,
that
Green
10
Bay-
knots?
yeah.
Green Bay's 10
Green Bay's
That-
10 knots.
That's also pretty remarkable.
That
Yeah, it
is.
And I think a 12-degree temperature difference or something,
Yeah.
less like that.
I mean, I think, so where was convection going at this time? I mean,
Probably morning, yeah, morning direction was around there.
so I mean, I would assume that you'd get some ascent based on just convergence
Yeah.
there at that
Isn't it like
point.
an old trick, you set up where you see like 1 o'clock, 12, you want to be where there's just a hint of surface easterly.
Yeah.
So
That's,
like as soon as you see the surface easterly burn off in the aliyahs,
Yep.
you're in a good spot.
yep. Absolutely. And then Caitlin's going to talk a little bit about the sounding tier, so here's the...
So as Professor Martin mentioned, Topeka 12Z sounding, it did have Cape, but that's one of the factors. So first off, we have a pretty moist layer, PBL to 850, and slight inversion, so that inhibited just enough the warm sector from, just junk convection firing into the warm sector to prevent any further installation. So that was one thing which had it going. Another thing, winds increasing with height, down here 50 knots at 850 to 100 knots at 250 and above. So it was a well synoptically forced event from the ground up to the upper levels. And you had, HODOs at 12Z weren't too great, but then again, this is 12Z, so you still had 8 to 12 hours of the local jet increasing, the service flow increasing, but it was all around just an impressive sounding at 12Z just to begin with. Lapse rates 8.4 Celsius per kilometer, ties into the flow coming out of the southwest with the elevated mix layer right about here, and having this much Cape on a 12Z sounding, it should ring some bells at SVC, National Weather Service, and whoever is in the area, because this is a very volatile scenario as is. And if we go forward to the 21Z, so this is Lincoln, Illinois. This was preceding some convection, and this is probably one of the most prototypical severe outbreak sound that you can imagine. Mixed layer, well deeply mixed to 700 millibars. Just a slight cap inversion at 21Z, but storms were ongoing later on. We had, I don't have 3 capes plotted here, but the cape within the lowest 3 kilometers is highly correlated with vorticity for stretching of the column near the surface, which is very a big component of tornado genesis. So when you see large values of 3 cape, you can reasonably assume that there will be an increased chance of tornadoes. And as we saw here, there is just a fair bit of 3 cape right in this sounding, and that's a very good estimate that there may be tornadoes.
What is that? What kind of cape are you calling it?
3 cape. So it's cape within the lowest 3 kilometers.
Oh, okay.
Yeah, and it's tied with vorticity, in accordance with vorticity. It enhances stretching of the column in the lowest portion of the atmosphere. But another big thing to note is the photograph shape. It has become very favorable for tornadoes. The slight southwesterlies at the surface may have just been an artifact, but overall, you get very good curvature, streamwise vorticity, and veering with height, which you need that for tornado genesis. And this is very typical for severe outbreaks. SRH, storm relative velocity, measure of veering with height, 387 is very high, and you see those values, you're like, oh, shoot, we gotta watch out. Cave values as well of 1500, it was unstable with a slight cap inversion, so with just enough forcing with the front or what have you, and things will go up like popcorn.
One other thing I'll note on the sounding quick is if you'll also look at the photograph, that blue line there is the right mover vector, which is just a kind of mathematical representation of how you'd expect a right moving storm to move, and that's 244 degrees at 51 knots. So that was another factor that really led to a dangerous situation on Friday, as the storm speeds were very quick. Yeah. And so next we just have kind of a visible satellite loop for Channel 3 imagery throughout the day. So you can really see, can I borrow this again? I'm sorry, thank you. So as the sun comes up, you can already see this dry punch really starting to take shape. So this is those really low, mid-level relative humidities that I was mentioning, and that really helped kind of drive some surface insulation in here across southeastern Iowa and into central Illinois. You can see kind of this was the elevated convection that was producing hail in the morning. A good kind of sign that it was elevated. As you watch it move northeastward, you can kind of see gravity waves move along with it pretty consistently here and well out ahead of it. But yeah, that was producing some pretty impressive hail in the morning. And then I'll wait for it to go again, and I'll show you kind of where the storms that we were chasing were. So I think, I believe this one was the one that we chased that produced the tornadoes. We kind of were sitting down here in the Burlington area for a couple hours earlier in the day, debating whether or not to kind of check out these storms coming out of Missouri. Kayla and I kind of thought that was kind of the meteorologically sound play, but ended up eventually going west to Iowa and thankfully seeing the tornadoes. But again, I'll note too, you can kind of see where the frontal boundary is, and note how far ahead of that frontal boundary these storms are firing. And so with this kind of larger synoptic ascent, it's not necessarily subtle forcing, but it's a little more subtle than this kind of crashing cold front. And so it can be a little more conducive, I think, for cellular storms that are going to produce tornadoes. And so you can kind of see just this outbreak of discrete cellular storms that ended up producing tornadoes.
One thing I've mentioned,
Yeah.
Up in South Dakota, I believe we have the release of some convective symmetrical instability in the cold, snowy areas that contributed to snowfall rates up to 3 to 4 inches an hour. And I'll mention briefly at the end that there was a pretty prolific blizzard up in the northern plains, which has increased the snowpack that Patrick had mentioned earlier.
Yeah, I wonder about the CSI because the flow is strongly curved that thing. So it's really a two-dimensional instability. So it might be negative equivalent potential vorticity, but it might not be CSI. It's just poorly stratified air that's being forced by large ascent. But I don't know. I'm not saying I looked at it. But I noticed the curvature, and that makes me nervous about that.
You can see the formation of the cloud band right at nightfall there.
Yeah.
Yeah, and that did not look fun to drive through.
No.
On the radar. In the next couple frames, it starts to form there, and then the sun goes down on it.
Yeah. And then we just
So
kind of
here's our trip. What time do we leave? 8:39. Left here, Dubuque, down to Davenport, down to Burlington, hung out around here for a while.
You took the scenic route.
Yeah,
exactly.
Because we saw some of the elevated convection come somewhat surface-based, so we saw some cells that had some a shape to it that looked favorable, but then we were deciding whether to go south towards the cells in Missouri, which would be near Quincy, or go back towards the developing cells in Iowa, and we made the choice to go west.
We changed our mind a couple of times.
We did, yeah. So we are very well versed with the Burlington Bridge.
Yeah, exactly.
But yeah, so overall around 11 hours if you just do this directly. It's a
Slower than that.
bit slower than that, yeah.
But yeah, good day.
Fun day.
And then I think then we just have, I put a little video here of the twin tornadoes. So really a pretty rare event, especially to have two as photogenic as this. So as Kayla mentioned before, that's the EF4 Kyoto tornado off to the right, and then what did you say the left one was an EF2?
Yeah.
Yeah. So there's that, and then a couple more pictures on the next slide here. So just, yeah.
Oh, that's nice. Is that the same storm?
Yeah,
Yes.
so.
That's the EF4 that you're looking at there?
This was actually the EF2.
This was earlier stages in the EF2 tornado, and then someone was gracious
also
enough
EF2.
to.
This
Yep.
is EF4. So
That- Yeah, go ahead.
I would say that this one probably was just as strong as the other one.
Yeah.
Just didn't anything, luckily. But you could just see the updraft bubbling
Yeah, it was
as
one of the-
far as you can.
Yeah, I mean, it was one of the craziest thing I've ever seen. That whole updraft column was just rotating, you know.
That's pretty awesome.
Yeah, it was incredible. I mean, just visibly, it was so much cloud mass moving so quickly. It was wild. And,
There's like a lot of water in that cloud too, though, not so much ice. It doesn't look
Yeah.
glaciated. I know that it is, because it's got a little fuzzy look to it, but it's not horribly fuzzy.
Yeah.
There's a lot of water in there.
Yeah. Yeah. So yeah, and then that's us in the bottom left with this tornado. But yeah, so that was it was quite a day.
One last one slide.
Yeah.
And then, as I mentioned earlier, the snowfall, so this is 72-hour snowfall over the plains. And anything above orange is about 8 inches to red is 24 inches. So pretty significant snowfall in a place that I've seen a lot of snowfall this winter. And lastly, so we saw the tornado reports, but this also produced a lot of wind and hail. So black triangles are large wind reports, and black squares are large hail. So with that elevated stuff early in the day, we did see the very large hail, and this continued through the night up to the operation line. So it was a very expansive outbreak of tornadoes, wind, damaging wind, and large hail.
Can't get over Lake Michigan.
Nope, cannot. A bit chilly for that.
Props to SBC though, I mean, they nailed this
Oh,
one.
yeah.
It
They
was,
sure did. And then the second one, the one that came on Tuesday, was
Yep.
almost the same places with high warnings, and they both came to pass.
Yep.
Excellent forecast for the whole week.
And they upgraded. Yeah, they did a 1630 Z upgrade to high risk, which was really smart of them, obviously, because it was
Right
day
here.
of. Yep.
Right here. It's
Yeah,
pretty
so
amazing.
incredible forecast. Nate, you know, this event had been something that had been apparent in the ensembles. You know, you just get a trough of that magnitude. You know, it's going to be, and so they've had this risk outlined for about 8 days ahead of the event, which is, you know, just incredible that we're able to predict with any confidence at that lead time. So
I agree. I think it's a phenomenal forecast. I think the northern moderate risk was easier.
Yeah.
In the sense that that's where all the synoptic forcing was strong.
Absolutely.
But then there's mesoscale stuff that forms tornadoes that I don't know much about. But I'm always impressed that forecasts in Dixie Alley are as accurate as they are. Because there's no cold frontal passage, there's no troughness there. That's not where things are really happening on that scale, on the things with which I'm familiar. And they get it right a lot.
Yeah.
Remarkable.
They're the best at what they do.
And I'll just say one thing, lower profile. There was a risk that we'd get an inch or so of snow on April that would have been excruciating because we would have otherwise had the snowiest March. We did not get that here, so there was no hangover of frustration on April 1. We just
Excellent.
didn't get any snow at all, so I'm glad about that. It's really a good thing about coming so close. But we had the snowiest March since 1959. That's still something to speak about.
Okay.
So, but not the snowiest of all time.
Excellent.
Give it over to.
Yeah, I got a few small ones. Is that good?
Yeah. Perfect.
Thanks, guys. That was
Yeah.
great.
Thank you.
Who else was on your trip?
We were chasing with our friends Charlie and Jonah on Friday, and then on Tuesday we went down with Layla, Bella, Aaron.
Let's go to the.
Oh, yeah. How did that one go?
Ice cover
Excellent.
first.
Oh, well.
Yeah,
Yeah,
so
so
we'll talk about that next week?
Yeah.
Start. Yeah, so just wanted to talk about the Great Lakes ice coverage. Kind of a dismal year, if I'm being honest. So here's a time on the x-axis there, and then the percentage of the total Great Lakes that were covered with ice. You see, it's, pretty much situated normally, maybe a little bit askew to the later end of the season. It has a tendency to positive feedback. When you have more ice, it sticks around for longer. But there's the whole lakes as a whole, and you kind of get the sense that these peaks in ice coverage occur just after we have big cold air outbreaks, right? The ice doesn't actually like to freeze when it's 120 knots on the lake. It kind of has to simmer down before that happens. So Pete, if you'll run back,
And it's not thickness either, it's just coverage,
just
right?
pure coverage.
Yeah, so it's hard to get a thick cover.
Right. So I guess we could try Superior. Really low year for Superior. Starting to feel bad for my furry friends on Isle Royale, you guys know about the wolves that live there. They're all inbred because the ice bridge that used to form there no longer forms. So that's a tough time for them. Supposedly a Canadian wolf came over when there was last a bridge, and they're doing a little better, but it's hard. So there's Lake Superior. I don't have much to say other than to point it out. And then Pete, why don't we go to Lake Erie? I think there's some interesting things to say here. So Lake Erie is remarkably shallow. I can't remember if it's 20 feet or 20 meters. 20 meters sticks to mind though, is like the average depth of the whole lake, which if you've done that problem where you figure out the mixing length of like a surface wave, well, a lot of times the waves on Erie will actually churn the surface of the bottom of the lake up. But Erie has that tendency as well. Once you get 100% coverage over Erie, the fetch goes down completely and the westerlies can't knock out the ice. So if you get to 100% early in the season, you're almost going to be ice covered for the most of it. And that has huge implications on the Buffalo lake effect snow time period, right? So as we change the climate, Lake Erie stops freezing all the time, and it freezes very weakly, and then a big westerly comes and wipes it out. And so we have a prolonged lake effect season in Buffalo. Versus, Pete, if you want to go back and go to Lake Ontario. Lake Ontario, similar size to Erie, also kind of the zonally oriented lake, but it's a lot deeper, and so it also tends to mix over itself pretty well, and so it doesn't freeze over every year. In fact, you can see most years it doesn't freeze all the way over. It has some of the least ice coverage of all the lakes. That leads to sort of a prolonged lake effect season on the Tug Hill Plateau. And Pete, if you'll go to the MODIS imagery real quick. Yeah, we can start out with this is Ontario, right? And here you can still see the sort of the snowpack on the Tug Hill Plateau. Remarkably deep compared to, sort of for its size. If you flip back to the Erie, here's Erie. You can just see how shallow it is based on all the sediments. So the waves actually churn all the sediments on Erie quite consistently. There's the Sandusky River that flows in, the Maumee River that flows in. Lake Sinclair is also very shallow, so it tends to have that same murky look to it. Little sand spit here in Erie, PA. It's actually a moraine that was left over from the glacial period. It left a bunch of boulders and stuff as it melted, and then sand piles up. But it's sort of like the barrier islands in Florida. You'd like to think we're better than them, but we also put break walls and build things on sand spits and expect them not to move. And then we have to build break walls to keep it there. So it's a state park, but it's kept there by break walls. Let's see, yeah, and then I guess if you'll go back and compare it to Lake Ontario, you can just see the visible difference from space. So if I'm an alien and I want to go somewhere where I'm going to find drinking water, I'm not going to land in Lake Erie. I'm going to land in Lake Ontario.
Plus, there's Cleveland to worry about.
Yeah. I know. Yeah, and I guess another little interesting one, people know their history, the Erie Canal runs off Erie and below Ontario. The Rochester and Sodas Bay area, nice way to ship before we had the railroads and trucks and whatnot. So there's a feeder between the Erie Canal and the top of Lake Cayuga. And so the top of Lake Cayuga also has that sedimenty look. You might not be able to see it from where you are, but kind of shallow up there. So if you're going to buy a summer home in the Finger Lakes, don't buy it on the top of Cayuga because you'll have a bunch of mosquitoes. Any questions about that stuff? I'm happy to take them. But Pete, if you wouldn't mind, could you go to the College of DuPage website real quick?
So Lake Erie gets a big burst of ice cover this year when Ontario is completely immune to it. Same with Huron, then? There's no big lake, no December ice spike on Lake Huron?
We could check on.
Well, we don't have to, I didn't, but I'm just curious because they're about the same latitude.
So, as I understand, Ontario, something about the mixing processes, it's out of my understanding,
Yeah.
but Huron's oriented in a way that doesn't have the same situation.
It's
Yeah.
interesting. I was just gonna say from like a seasonal perspective, the
Department of Transportation is really interested in whether or not it's gonna be an early or late freeze season for Buffalo.
yeah.
How much salt and sand are they gonna need? And, you know,
Salt futures.
yeah, exactly.
So if there's any way to say that, I mean, you gotta just
Right.
know when it's gonna get cold there.
Yeah.
And that's hard to do, isn't it? Yeah, it's-
Just Pete, under weather analysis tools, you go to the numerical models. And then to the wrap on the short range. And then if you go to select run. Right here. Let's go to yesterday at 12Z. So for those who don't know, I coach sailing on the side. I also forecast for sailing as a side hustle. So if you click on our area, Pete, one of the big things I'm concerned about in the spring or when I'm forecasting for someone is they want to know what the biggest wind gusts they're going to see while they're sailing. You'd like to be able to tell them that. It's one thing to just like look at the HER and go to the wind gust page. You can try that. But Pete, if you go forward here to until maybe 18Z on Friday, the slider here, just drag here and keep going back to Thursday. I'm sorry, I'm at Thursday. Go back to Thursday, let's do 18, that's fine. And then click right around here and just hold. So you get a point sounding. I'm just using the wrap because they actually let you take point soundings with the wrap. I think you can do HER with topical tidbits for those who are wondering. But a clean way to forecast your peak wind gust. Go down to the surface and follow up the dry mix layer, or the full mix layer. And then at that height, that pressure level, find your wind barb that's appropriate. And that might be a good estimate of the top gust that you'll see at the surface for the day. And then you can subtract a few knots if you think there's going to be trees in the way. Doesn't work every time, but it's a relatively good one. Another one I'll point out, very little directional shear in this sounding. So for someone forecasting wind for a sailboat, or maybe you're forecasting for a prescribed burn and you want to know if there's going to be a shift of the burn in a certain direction with the persistent wind gust, look at the amount of directional shear in the boundary layer. If the winds at 925 are 20 degrees to the right of the surface winds, then you can expect your fire to move to the right relative to the fire's perspective of the fire motion. So that's a good trick too. And if you're having a hard time finding the top of the mix layer in some of these soundings, right, it's not always so clear from dry adiabatic to something else. You can always look for a shift in the winds, and typically there's a slight shift right at the top of the mix layer. So, I don't know, some wind forecasting tricks, if you're into them. So I canceled practice because 30 knot, 25, 30 knot is not great. Anybody else got anything?
No, that's cool, thanks.
Yeah.
All right, thanks, everybody.
Oh, Pete, did you want to show do we have the ones from the email? Oh, about Madison, that was cool. It's short. 1 minute.
Yeah, except I gotta get back.
And then next week, you guys will maybe have something for your last? That's great. That'd be great. It doesn't have to be the whole thing, but just something.
You gotta remind me who sent these in again?
It was Ed Hopkins.
Oh, Ed Hopkins sent in some
State County
stuff.
Health Office, yeah. He's the one behind those climate maps, the
Oh,
Madison
awesome.
temperature preset.
Yeah, those are sweet.
Yeah, we're gonna go through all my important emails.
You could go to send, you send them to us, right?
Could do that.
All right, so this is the duration of ice on Lake Mendota.
Oh, yeah.
Here's the median, maybe?
Oh,
The
5.
red is a 5-year running mean.
Oh, yeah,
I got the
okay.
annual values.
And then here's kind of my take at the
Definitely decreasing.
the trend. Definitely decreasing. How about that?
That's crazy.
21 days.
21 days.
In 2001, 2002. That's incredible. And then 161 days of ice back in 1880. So the third trappers, I guess, were
That was the
on
year
their
of
last
the
legs.
blizzard in March in the Great Plains. It just got warmed up.
Okay, that's right, that's right.
And what did we had the amount of freezing days, right?
Well, while you're finding it, I was fooling around at the end of last week. Do you know what calendar day has the biggest difference between the all-time high and the all-time low in Madison?
March 23rd.
March 20th, pretty close. March 20th is the day. It's 88 degrees difference. It was 80 in 2012 and -8 in 71 or something like that. So that's it. It's really interesting. It's always around the equinox.
All right, so I guess if I'm reading this right, we got the green is the average cumulative freezing degrees, like the number of days that are below freezing.
For an average high?
I think it's
for the average
I think in the
climate.
email, he describes what it actually is. It's summation of departure of daily average temperatures below 32 degrees is what that is.
Daily average. Okay, daily average. Okay.
Sure, so I guess like the,
Green is the normal, blue is this year, and the green dots are the Lake Monona ice in and out, and red diamonds are.
so right as we start to get more freezing days in a row, all of a sudden, bang, they both go. And when we flatline,
Yeah.
we start to lose them. I think it's a big wind event often that does the job. But that's pretty remarkable. I feel like if Madison wasn't developed, it'd be a better bird watching town for waterfowl.
As the years
Now
go
than
forward,
it was
yeah.
back in the
That's
day.
right, yeah, that's right. Season would be longer.
Longer bird watching season, but I think maybe the buses and the buildings have something to say about that.
Yeah.
So,
All right, thanks. Thanks again, you guys.
Yeah.